Immediately after engine cranking, the distributor sends an engine speed signal called an NE signal to the ECU. The FC terminal of the ECU is grounded as a result, and current flows to coil L1 of the circuit opening relay. Therefore, the circuit opening relay remains on while the engine is running, even after terminal ST of the ignition switch goes off, so the fuel pump continues to operate. Now, if the fuel pressure remains at 0 during engine cranking, we should check to see if the fuel pump is working normally by shorting terminals plus B and FP of the check connector. In the case of a multi-pin type connector, we bypass the circuit opening relay like this, and with the ignition switch in the on position, apply electric current directly to the fuel pump. This is what the fuel pump sounds like when it operates, and the fuel pressure will rise to the standard value. This sound tells us that the fuel pump functions when we bypass the circuit opening relay, which indicates that there is no problem in this circuit. Therefore, we must check the circuit opening relay circuit and this circuit also. So, let's check the circuit opening relay and its power supply. First, remove the relay from the circuit. Then, measure the voltage between terminal plus B of the relay connector and body ground. Let's see how to check the power supply. If the measured voltage is equal to the battery voltage, check the circuit opening relay itself. With the battery connected up to the STA and E1 terminals, measure the resistance between terminals plus B and FP of the relay to see whether relay contacts have closed. If there is no continuity between plus B and FP, there may be poor contact between the points. Or there may be an open in coil L2. If the ohm meter reads 0, we can conclude that the circuit opening relay is okay. So, crank the engine to measure the voltage between terminal STA of the relay connector and body ground. If the standard voltage is not being applied, there may be an open in the wire harness between these two points. If the measured voltage is equal to the standard voltage, there may be an open in the wiring between the relay and the fuel pump. If the relay is okay, reinstall it and check this circuit next. To see if the standard voltage is present at terminal FC of the ECU with the ignition switch in the on position. If there is no voltage, there may be poor contact in terminals plus B or FC of the relay. Or there may be an open in coil L1. or an open in the wire harness. If the standard voltage is being applied, crank the engine and see if the voltage at terminal FC of the ECU drops. If the voltage does drop below 1 volt, the trouble may be due to poor contact at terminal FP of the relay. Now, let's crank the engine and see if the voltage drops below 1 volt. Here, the voltage does not fall to below 1 volt. This could occur for a number of reasons. For example, terminal E1 of the ECU may not be grounded properly. Or the ECU itself could be at fault. The next test is to short terminals plus B and FP of the check connector like this. But we can't hear the fuel pump operating, can we? Since the fuel pump does not operate when we bypass the circuit opening relay, the fuel pump itself may be out of order. Or there may be a problem in the power supply circuitry. So, we check the voltage between the terminals of the fuel pump connector to see if it is equal to the standard voltage. If it is, this means that voltage is being applied to the pump. So we can conclude that there is a problem in the fuel pump itself. Now, let's see how to actually check it. If the voltage at the fuel pump connector is 0, there may be a problem in either the fuse, the EFI main relay, or the fuel pump grounding circuit.
فراموش نکنید که توی کانال سابسکرایب کنید و کانال رو با دیگر دوستانتون به اشتراک بذارید. تا ویدیوی بعدی، روزگار خوش.